TCP/IP was always meant for, robust communication. It was not meant for security, and that's why a lot of protocols had to be developed to make the entire TCP/IP suite into a secure system. Okay, so we will understand certain, protocol security mechanisms as to how, a lot of protocols have developed over a period of time on the network layer to make it more secure. The first is the authentication protocols. The first protocol amongst them is PPP, point-to-point protocol. Point-to-point protocol is a protocol which helps network devices to authenticate to each other. Okay, so suppose your ISP has deployed a modem in your premises, and first time when it communicates to the ISP's, router, how does the router know that this is an authorized device? Okay, so PPP helps in establishing the identity and authentication of a network device to itself. Okay, but the problem was PPP used to pass the username and password into clear text. So that was not a good system. So over a period of time, protocols have been developed which allow for secure passing of username and password data for network devices. Basically, these devices, these protocols are meant to authenticate devices to each other. Like we human beings, authenticate by username and password, the device also need to authenticate to the next device. Okay, and PPP was used for that particular task. 802.1x, was the authentication. I'll say 802.1x was the class of protocols, or IEEE 802.1x was the standard which was laid down for securing network security for devices. So when devices are authenticating to each other, 802.1x is the protocol used for identifying and authenticating each other. What was the vulnerability? Man-in-the-middle attacks could happen because the sessions were not secure. Sessions could be hijacked. So IEEE 802.1x was not inherently secure. So you have to ensure that your devices which are connected to your ports are secure. And how do you do that? Generally at the network layer, you bind the port. You do something called port binding, wherein the MAC address of the machine is binded to a physical port, that only this port, only this machine can only connect. Such kind of security is called port security, physical port security. Then networks are, their quality is defined by quality of service, that how much is the bandwidth, what is the latency, what is the packet jitter rate. So quality of service provides you an overall figure as to how is the network behaving like. Okay, so that is a term used for seeing the quality of your network. Now, on networks, you also rely for voice communications. Now, erstwhile voice communication was carried out on PSTN systems. What are PSTNs? You had physical exchanges which laid line up to your premises, and you had a telephone connection. Over a period of time, PSTN services have died down. Then came PBX. PBX are again exchanges which are hosted inside your enterprise. They again work on the same fundamental. Okay, but only thing is they are inside your premises and phones were connected. But now even PBX is a obsolete technology. What has come in is VoIP. So on the same data network switch, which is coming to your terminal, you can also have a small IP phone connected to it, which can help you in your voice communication. Like PSTN was vulnerable to a lot of man-in-the-middle attacks. Why? Because the exchange had physical copper cable going to your premises, and anybody could tap onto these two lines and can listen to it. Okay, PSTN was also used for phishing attacks. Earlier, if you want to make a long distance call, okay, you had to do STD ISD 011 0 plus 1, okay, 001. So you could actually fool the exchange by finding out the ISD dialing codes and long distance call dialing codes. So that kind of hacking was called phishing. So preking was basically trying to find out the DTMF tone for making a outward call. Okay, PSTN more or less is a dead technology, not used, right? Old systems might be running, but new systems don't use PSTN. VoIP is now the most preferred way of voice networking. Okay, and most of the places, this is deployed. What happens is it's a IP phone, which allocates a IP address to your device and communicates on the VoIP protocol. Because VoIP protocol makes you transmit your voice on a secure network. It can be riding on a HTTPS session. So right now we are talking on mix of VoIP and CDN network over HTTPS tunnel for this voice communication to happen. Right? Like any voice communication, it will be susceptible to man-in-the-middle attacks, session hijacking, denial of service, wishing attacks, somebody pretending to be me. Tomorrow I might give you a call on the WhatsApp and say, "Hey guys, listen, I'm in a deep trouble. Can you just help me out with?" You know, so that kind of things are happening today. Even AI replication calls are happening. So there's a lot of things happening. So you need to be aware, and your users need to be aware of such issues. Right? 1 second. Reports just.
The best ways to protect check. Okay, my AirPods are discharged. So best way to protect your VoIP systems are application security, having strong password, MFA. Okay, blocking international calls, use only trusted software, don't use untrusted software for calling, right? Most of the organizations don't use Zoom, they use only Teams for their meetings. The way you can protect your systems is by having network intrusion prevention systems, VoIP, and a lot of application security measures for your SaaS-based softwares like Zoom and meetings and Google Meet, right? So there is something called, call hopping. So a lot of people, they share addresses with, unsuspecting people, and then those call links are, shared, and some unknown people might join the call. So you have to be very, very, be aware of who are the people who are attending your calls. Wishing is a technique by which basically you fool other people to believe you, okay? And you always request a proof of identity whenever you have any suspicion over who is calling. Always are on the negative side. That's the way you save yourself from wishing. Pricking, I already told you, it's now no more relevant. Pricking was when you could find out the dialing codes of international calls and long distance calls, okay? Phreaking was the technology used by hackers to find out the dialing codes. We have done it ourselves also. It used to come with a box with a lot of DTMF tones. Okay, so you press a tone, press a combination of tones, and then dial the number to see whether you can go outward dialing or not. Then PBX, fraud and abuse. If you have a PBX system in your enterprise that can be used, that is used by customer support. You see the recent hack at MGM happened because of not PBX, but voice fraud and abuse. Somebody called the customer support and said, "Hey, please change my username password." Username password was changed. And then MFA continuous request was sent to one particular guy who by mistake clicked, and the MGM account was one of the accounts, and that was an administrator account which was hacked. So such fraud and abuse attacks will take place on voice-based systems. Okay. Generally, one of the simplest way of having voice-based, identification is to identify the distant and always have, auditing and acceptable use policy, logging all what is happening on the voice networks is very, very important. You should always block remote dialing on your enterprise systems. Okay, any systems which are VoIP based, you should ensure that having proper patching and updation of the systems. Okay, so DISA. Okay, this is obsolete now. PBX generally is not used anywhere now. A lot of times you are now using remote functionalities, so you have to, at times configure security remotely. So that you generally use something called RMM tools, remote monitoring and management tools. So you use these RMM tools, they activate certain protocols like SSH and Telnet to give you remote access. Okay, so that means on the remote PC, they will run a remote Telnet server and then you can connect. Such tools, though very easy, give a very big, wide vulnerability, to your systems. Use of RMM tools has to be done very, very cautiously and needs to be monitored. The SolarWinds is one of the ways in which, hackers hacked a lot of government systems because SolarWinds had an inherent vulnerability, and SolarWind hack led to a lot of US government systems getting compromised. Okay, SolarWinds is one of the prominent RMM tools which is used by government contractors and government officials in US. Okay, so remote access and telecommuting has become the one of the major things after post-COVID. I can take classes online, you can take, you can work online. So telecommuting is a very important facility now, but it has become also given rise to a lot of vulnerabilities. So there are many times wherein you have to maintain specific controls, like how are you going to give the device, what kind of application is going to write, what is the security patching management of remote users. So a lot of RMM tools, the requirement is of RMM tools and remote monitoring, which helps you in monitoring your remote clients. So you need to ensure that remote users are secure either by using VPN or by ZTNA or a CISSP Cloud Access Service Broker. So you need to have one of the three to provide a secure access to your remote clients. Okay. One of the best way of always having remote users, if they are users, is to implement always strong authentication with MFA and least privilege. Okay, session should always be encrypted. These are three main things which you should always use for remote client security. Okay, then you also need to have a remote access security policy inside your organization so that whenever you're engineering remote access, you know what kind of network, what is the application which is going to write, and what kind of communication security arrangements needs to be there between the remote user and the remote access methodology. Then we have a lot of multimedia collaborations these days. We use Zoom, you have Google Meet, and you have Microsoft meetings. You need to have a small policy for it so that because today, if you look at Microsoft Teams or Google Meet, it gives you email, it gives you storage, it gives you voice networking, everything at one place. So you need to have a security policy how to access these particular applications. Generally, organizations which are cloud first are using ZTNA for managing their access, because VPN somehow slows down and there are a lot of restrictions on VPN, and that's why ZTNA, organizations which are cloud first and have remote first policies, are going for a ZTNA kind of access methodology. Remote meeting, we all know, always use strong authentication, strong encryption protocol should be there. Okay, and you should always see audit and logging, and no unauthorized users are joining your remote meetings. Okay, IM and chat, instant messaging and chat services has become very simple to use, but it also gives a vector for any kind of social engineering attacks. And with AI coming in, you will see more spoofing attacks wherein somebody is calling you, but actually that person is not the person who is meaning to be. So you have to be very, very careful and be very, very, sharp to detect such social engineering attacks. Okay. Then one of the fundamental, once you are planning your networks, load balancing is a factor for availability. Okay. What load balancing does is it transfers your load into multiple resources so that there is adequate availability of your services on a network. Okay. Now, load balancing can be done using a variety of techniques, but major part of load balancing is to basically maintain availability. Now, there are two kinds of load balancing systems. Okay, one is to have efficiency. Okay, say suppose you have a load balancer and it directs the traffic 50% on both the resources. What does this mean? This means optimum utilization of your resources. You are using the resources optimally. Okay. But if you are, this is for efficiency. But if you want to use for high availability, then what will happen is a load balancer will give all the load to resource one, and the second resource will not take any load. But the moment this load start exceeding the limit, then the load is transferred. That means it increases the efficiency. It increases the it increases the peak load. That means it helps you in taking more load. Okay, that is how high availability can be programmed.
So in this case, sir, both the load balance, I mean, both the devices will pass on the traffic.
In the first one, both the devices. First one, 50% here and 50% here, right? Here, right now, what happens if you get 100% load here and 100% load here, you are able to handle 200% load, right? In the second arrangement, you are only able to handle 100% load.
So it is a failover mechanism. Like if once
it's a failover. It's a failover.
Switch it over to another one, right?
You can have a failover or you can have optimum efficiency.
Okay.
In this case, you are catering for peak load. You are catering for additional load. Okay. And in this case, you are catering for
availability.
Service availability.
Okay. Thank you, sir.
Right. So that is how load balance is planned. Now you can have a lot of ways in which this can be arranged. Now you imagine that if I am doing a load balancing based on IP, okay, Indian IPs will go to this system, Australian IPs will go to this system. So this is called context-based offloading. Many times you would have seen, your data going to a particular region only. Okay, so this is simple IP-based, load balancing. You can have TLS offloading. There are multiple techniques in which you can do. There's a variety of techniques, but that's not the aim. The aim is to understand that you have either failover or you have minimum assured service or peak load capability. Okay. At times, load balancers can also, have persistence. That means first time I came and accessed a service, okay, say A came for a particular IP, the load balancer knows that A's traffic was last time given on a particular route. So let's now this time also route his traffic to particular route. That is called persistence of load. Okay. Now you can have arrangement of active and active passive. We just saw that you can have load balancing on active and active. This gives you 200% availability. And active passive is for failover. So you have one going and the second, this one fails and the passive takes over. Okay. So that is called active and active passive. Now, lastly, we come to few more protocols and then we will end the class. Okay. Email is used on SMTP port 11. SMTP is the protocol which is used for email, TCP port 25. And to retrieve the email, you use IMAP, TCP port 143 or POP port 410. Basically, when you send the email, once you send the email, this email is sent using SMTP. It reaches the server sends it to the next server, to the next server, to the next server. It keeps on going till such time it reaches the server where your mail actually supposed to go. Now to receive my email, I keep on querying my server. Whenever I get a message that, okay, mail has come, I retrieve the email using IMAP or POP3. So whenever you configure your email clients, you tell them either IMAP or POP3, which is the protocol by which you want to retrieve your mail. Okay. And X.400 standard is used for addressing the emails between you and your server. You need to secure your SMTP servers because this is where your messages are going. From client to the server, and SMTP servers are like any other servers on network. You need to protect your servers in the same way where you protect your enterprise servers. But these days, most of our email is on a SaaS platform, either with Google or Microsoft. So we don't handle SMTP relay servers ourselves. Okay, 20 years back, we were handling the entire SMTP servers ourselves because the email was being managed by us. There was no email service provider. Okay. Now there are SaaS-based email solutions. The main threat is social engineering. Somebody is trying to brute force my password, get my MFA, and log in as me inside my enterprise network. So that is the SaaS-based emails. Like my enterprise email runs on Microsoft Office 365. So Office 365 is a SaaS-based Office tool wherein you have email, you have ERP, you have everything that you can ask for, right? Even identity management also. So the only way hackers can get in is probably by hacking somebody's username, password, and MFA. Okay, so the best major risk is of social engineering. Okay, emails are inherently not secure. You need to have a lot of authentication and authorization for securing your emails. Email backup policy should be there inside your organization. Okay, email is generally plain text. Generally, emails are spoofed. There is spamming on your emails. Wastes a lot of data on your waste a lot of storage space on your email inboxes. There are a lot of security solutions which are available, standard email security solutions which can protect you from spams, from spoofing, from I will say email hijack attacks. So it's a good solution to always implement email security solutions in your organization, right? To protect your domain name, right? You generally activate DKIM and SPF for your domain. Always remember that. Whenever you are using your domain for emailing, you need to protect your domain for emails using two protocols. One is DKIM, Domain Key Identified Email, and Sender Policy Frameworks. Basically, they protect your domain name from somebody taking your domain name and spoofing your domain name for sending some kind of emails to organizations. Okay. PGP was a secure emailing technique which was developed by a person, and it was banned initially, and then it became a standard for email security, wherein I can send you an email using a lot of encryption methodologies. Okay, REST email is okay. Now, how you implement you can implement DKIM and SPF. Okay. Once you implement DKIM and SPF, you can implement it using something called DMARC solutions. Okay, so DKIM is the public key private key arrangement to safeguard your domain name. SPF is the protocol which is used to protect the entire DNS hierarchy of emails. Okay, I don't want to go deep in because that will create confusion. The way you protect your email system from spoofing attacks is by implementing DKIM, SPF, and DMARC. Okay, it's a public key private key arrangement. If you read a little bit, you will understand it's not very complicated. These are the basic tools by which you can protect your domain name for your emails. VPNs I have already discussed. Okay, this VPN is something called tunnel mode and a transport mode. Okay, you create site-to-site VPNs between two offices. So two routers, you have two offices, you can create a site-to-site VPN between your offices. Okay, VPN I've already discussed. This is also known concept of tunneling. I've told you how VPNs work. Yeah, so how VPNs work is VPNs have, once you form a VPN packet, you have something called an IP header, IPsec header, and a data payload. Okay, for tunnel, you don't need this, this IP header. Why? Because you don't need to know where the data is going, because it's a tunnel between two networks. You don't need to know who is the client. So therefore, this is also encrypted in tunnel mode. Whereas in transport mode, this is not encrypted. This is his favorite question in CISSP. It will try to test you. Okay, that in transport mode, your header is unencrypted because it knows to know to whom the message has to go. Okay, VPN mode, tunnel mode, I've already told you. Okay, and so few common VPN protocols are IPsec, we've just seen. We also have PPTP, point-to-point transport protocol, layer 2 transport protocol, SSH, and OpenVPN. These are all the ways in which you can implement VPN protocols. Okay, PPTP, it's an obsolete protocol, not used anymore. L2TP is used on Windows clients. Okay, you can connect. So L2TP is basically you can connect from your machine to a VPN service directly. Okay, you don't need a client in between. Okay, that is the protocol itself handles the complete VPN packets. SSH is a protocol I've already told you for accessing remote servers. Okay, so but the same protocol can also be used for creating VPNs. Generally works on TCP port 23. Favorite question in CISSP. OpenVPN. OpenVPN is a standard. It's an open architecture standard. You can take the source code and implement your own VPN architecture using OpenVPN. It's based on transport layer security. Okay, IPsec, I've already told you. IPsec is a protocol for implementing VPNs. What you should know, the infrastructure you require for IPsec. First is an authentication header. Now, IPsec packet has a something called an authentication header and a encapsulation payload. Okay, so your data is here and your addressing is here. Okay, that is given by the authentication header. This is called the AH and this is called the ESP. Encapsulation security payload. This is the encapsulation security payload. Hash-based, HMAC-based code. HMAC protects the integrity of your data. Okay, in a IPsec VPN. IKE is the Internet Key Exchange. Now, whenever you have to do an IPsec, there is going to be an exchange of private and public keys. So IKE handles those public and the PKI infrastructure. IKE is the PKI. This is completely the PKI infrastructure. For key exchange, SKEME protocol is used. For key generation, Oakley is used. And for managing the keys, Isaac MP protocol is used. So this is something probably I might ask you to remember for CISSP, but still it will not check. Okay, it will. I have not seen anywhere being checked for this. Okay. Then switches and virtual LANs. Switches are used for connecting your devices on premise, and virtual LANs help you in creating your own official small network segmentations on a single switch itself. Switches are, they operate at layer 2. There are two types of switches, managed and unmanaged. Okay, unmanaged switches, you cannot do any configuration. Managed switches will let you do some kind of configuration. Managed switches also let you do some forwarding. Forwarding means you have, if you want to listen to complete device, okay, so one port, all the data you can forward to one port for listening. This is generally network security professionals. They want to see the packets on the network. Okay. Also, you can program switches for dropping certain packets if the destination address is not on their network. Okay. VLAN is a concept by which you can use one single switch to create virtual LANs inside one switch itself. And you can extend this VLANs to another switches also. Okay, basically segmenting your network inside a network. Okay, generally switches are prone to flooding attacks. Flooding attacks means, as I told you, if this is my switch, I've got an ARP table, I will try to flood your ARP table in such a manner that I carry out a denial of service attacks. The best way of protecting your switches from such attacks is by using a network intrusion detection system. Okay. NAT is a technology by which you map your internal network to external network. Now, as I told you, you have a network perimeter. Your internal networks generally work at 192 series or 172 series or 10 series. And external networks are working on the complete IP. A NAT sits between your internal and external networks and controls what data is going outside. It masks the internal network, and outside network, it is single IP which is visible. Whereas internally, there must be a lot of people. So externally, it is visible as one particular IP. So to external network, it is visible that all data is coming from this IP. Whereas internally, actually, there are a lot of people who are sitting and accessing that particular IP. So the protocol, the technology which helps you in doing that is called NAT, Network Address Translation. It is nothing but a table which says, okay, from this IP data went to there. Okay, so it basically notes how to map what is the data coming from outside to inside. I already told you 10. Series is for private IP, 172.16 is a private IP series, 192.168 is a private IP series. You can use these IPs are not routable on internet. They will never get routed to internet. Okay. Right. Also, at times, if your internal IP addressing scheme fails, Windows has a feature of allocating you a IP address from 169.254 to 169 complete series range. That is called APIPA, automatic, IP addressing allocation. So why? Because at times your system may need an IP, but there is no one to allot him an IP. So Windows has its own IP allocation service by giving you some kind of address so that you can, communicate on a network. Now, for network connectivity, you're always dependent on third parties, either on ISPs till now. Now you are also dependent on ZTNA service providers. So if you are taking your connectivity from Zscaler or someone, now you will be dependent on third parties. And for dependence on third parties, you always have third party risk. And how do you manage third party risk? By SLA. So these are favorite questions. Third party means you need to have a SLA, you need to have a contract. Okay. There are two kinds of switching. One is called circuit switching and one is called packet switching. What is circuit switching? Erstwhile, telecom systems where you had telephones physically. So to connect you to another telephone, you actually had a physical line which was connecting you. Such kind of systems were called circuit switching, where physically some circuit is getting switched. Whereas internet is a packet switch technology, whereas packets are reaching your routers. Okay, multiple packets are reaching the router, and depending upon where the packet has to go, the packets are routed on different circuits. This technology is called packet switching. Okay. Virtual circuits is obsolete. It is no more there in the course. Now, WAN technologies. Now, WAN technologies is how your router connects to the network. Okay. Erstwhile, now this is all obsolete. Now you are connected actually not on T1, T3 circuits. You are actually connected on STM1, STM2, STM3. Okay. T1, T2 are the basic parameters of network connectivity. So what happened 20 years back? The T1 gives you 1.54 Mbps. Now, all calculations in the T1 region, that is in the US region, are calculated in the multiples of T. And in the European region, oh, sorry, I'm wrong. T1 was European standards. American standard is E1. E1 is 2.048 Mbps, right? So we all follow American standards. So it is E, and Europe follows T standards. Okay. All multiples of WAN networks today, if you see, even if you see STM1, which is 155 Mbps, is actually 2 into something. Okay. So 2.048 becomes the base calculation of your network speeds. So WAN technologies, two major WAN technologies. One is the T1, T3, okay, and E1 and E3. Okay, T1, E1 is 2.048 and E1 is, I think, 51 point something, I think. I don't remember, or 48 Mbps, something like that. Right now, the WAN technologies has changed. Mainly WAN technologies used today are ATM and IP MPLS. Okay, these are the two WAN technologies which are majorly used behind your ISP. So you are connected with a modem to the ISP. ISP is connected to different network providers using either IP MPLS or ATM. ATM is also now obsolete. It is primarily IP MPLS. And IP MPLS works over actually fiber optical cables. Fiber optical cables are there on your seabed and they connect different network providers to each other. Okay, using technologies called synchronous digital hierarchy and so on. You don't have to remember all this. You basically have to understand that what is it that fiber. So fiber gives you, high speed network speeds, 51 Mbps, 155 Mbps up to 40 Gbps. For controlling security on the networks, you need to have two things. One is transparency. Users should not be able to see security. So it should be transparent to users. And that's why generally when you put a firewall, users don't feel whether there's a firewall or not. So it's transparent. Okay. And transmission management is very important because you have to do logging. The network handling network was a difficult task till now because there was a lot of devices, a lot of management used to be there. With SDN and SD-WAN coming in, requirement has come down. However, security control requirements will always be there on the networks, always. Main networks which will happen on networks is denial of service attacks, impersonation, identity and authentication issues, replay attacks will happen. Eavesdropping will be a major challenge in wireless networks, and ARP poisoning on switches will be a challenge. Use NIDS, VPN and IPsec.
Thank you for watching. Don't forget to subscribe our channel.